Hello everybody, welcome to my YouTube channel. Today the topic that we're going to deal is bitwise operator, which is very important in the case of embedded systems. So whenever you're taking a microcontroller, you're going to give these inputs as bitwise inputs. So you need to know the operations that is happening with these bitwise. You need to do AND operation, XOR or operation according to the requirement, according to what kind of output you need. So once you know to efficiently deal with these bitwise operators, you are efficient in writing an embedded C program. So to become an embedded engineer, this topic is very important, so please understand. So these are the basic operators which you all might be doing. AND operator, we have got an ampersand sign. For an OR operator, we have got just a line. For a complement, we have just got a wave. And for XOR, we have got an arrow in upside arrow. For right shift, you have got two greater than symbols, and left shift two less than symbols. So these are the basic operators. This is the output of a truth table for an XOR operation. You also need to know the output. You also need to know this is in the case of XOR. Okay, you also need to know it in the case of OR and also in the case of AND. Okay, let's see for OR. In case of OR, if any one of the input is high, the output is going to be high. Otherwise, it is going to be a 0. Rest all will be 1. In case of AND, okay, let me complete this one first. 1. Okay, any one is high, output is going to be 1 in the case of OR. In case of AND operation, any one of the input is 0, output is going to be 0. Zero, 1, 0, 0. Okay, so in order to detect if the input is, if a bit is 1, you just need to AND it with 1, and if you get an output as 1, then that means that bit is going to be 1. Okay, if you need to know if a bit is 0, you just OR it with 0. So when you OR it with 0, if you get a 0, then that is the input is going to be 0. To detect 0 and 1, this is the logic. Okay, to find if it is 1, just AND it with 1. To find it if it is 0, OR it with 0. When you OR it with 0, in all the other cases the output is 1. So, okay, if you want to know, see, if both the inputs are same, then XOR output is going to be 0. If both the inputs are different, XOR output is going to be high. So just understand the truth table. Not table, you will be knowing if input is 0, output is 1, input is 1, output is 0. Okay, now let's do some programs. Okay, now let's start with the right shift and left shift. Okay, I'm going to give an input as 5. 5 will be something like 0, 1, 0, 1 in the case of bitwise. Okay, so when I'm going to shift it to left and when I'm going to shift it to right, what is going to happen? So 0, 1, 0, 1. I'm going to shift 2 positions to the left. So it will be 0, 1, 0, 1, 0, 0. Okay, so 0, 1, 0, 1, 0, 0 is nothing but you have got a high position at 4 and 16. So 16 plus 4 will give you 20. So when you left shift, if by 2, you're going to get the output is 20. And when you're going to right shift it by 2, 0, 1, 0, 1, when you right shift 1, 0, 1 is going to get out. Only 1, 0, 1 will be only one of the 0 1s will be remaining, that is 0, 0, 0, 1. So the output is going to be 1. Okay, I'll just write and show it to you so that you can understand. Okay, here I am taking 0, 1, 1, 0, 0, 1. When I left shift it with 2 positions, when I'm going to left shift this by 2 positions, what happens is 0 1, it gets shifted to the left. So what is this output? This is nothing but 20. Okay, when I am going to right shift it with 2, then what happens? So the one of the 0 1s is going to exit and only this will be remaining, so the output is going to be 0 0 0 1. So this is nothing but 1. Suppose instead of 5 I am taking 6. Okay, suppose the input is 6. One example, 0 4 0. Okay, I'm going to left shift it by 2 and I'm also going to right shift it by 2. So when I'm going to left shift it by 2, what happens is I get 0 1 1 0 0 0. So what is that? It is going to be 16 plus 8, right? 24. This is nothing but a 24. Okay, now when I'm going to right shift it by 2, it is going to be 0 0 0 1. That is nothing but a 1. Okay, so this is in the case of 6 and this is in the case of 5. So let's do with 5 and check the output. See, it's 20 and 1. Now let's redo it with 6 and check the output. It is 24 and 1. Okay, so this is how you get left shift and right shift. Now let's do C, A, A and B, A or B. Okay, now this is another example for AND and OR operation. 5 and 6 you're going to AND it, and 5 and 6 you're going to OR it. And okay, 5 means 0 1 0 1 5, and 6 0 1 1 0. So when you're going to AND it, you will get 0 1 0 0. So this is nothing but, what is that? 4. Now when you're going to OR it, OR 0 1 0 1, yeah, okay, 0 1 0 1, 0 1 1 0. So when you're going to OR it, what you're going to get? This was output here. Okay, when you're going to OR it, what you're going to get? Yeah, 0 1 1 1, 0 1 1 1. So this is nothing but 7. So now let's check the output here. 4 and 7 is the output. I hope you can see the output. Okay, and I hope you have understood the logic also. Yeah, this is the AND operations when you AND 5 and 6 and when you OR 5 and 6. See, in case of AND, only if any of the input is 0, output is going to be 0. Only if both the input is high, output is going to be high. So it gives you a 4. In the case of OR, if any of the input is high, it is going to be high. Only if both inputs is 0, output is going to be 0. So then you get the output as 7. So this is AND operation, OR operation. You have done left shift, you have done right shift. Now let's check complement operation. How does a complement work? Check it with the C equal to complement of A. So A I am going to give it as 5. What will be the output? Minus 6 is showing as output. So how come 5 complement is minus 6? I will show it to you. So 5 means it's nothing but 0 1 0 1, right? So whenever you take complement, it is going to give you the 2's complement. So first what happened is, see, this will be some 8-bit or some kind of operation like this, right? N number of bits will be there. So the last bit will be the sign bit. So first when you do a NOT, what happens is, all this becomes 1 1 1 1 till what? 1 0 1 0. So this is the 1's complement. When you take 2's complement, you're going to add a 1 to this. Okay, when you're going to add a 1 to this, what happens is, this whole thing will be 1 1, and then what happens is 1 0 1 1. Okay, this is what you're going to get. So so when you take it, see, first you take a complement. Again, okay, it's not like this, sorry, just excuse me. Okay, what happens is, first you take the complement. Okay, let this be the sign bit, the last bit. Okay, when you take the NOT, it comes like this. Again, to take the 1's complement, what happens? Sign bit remains as it is. This whole thing changes as 0 1 0 1. And again you are going to add a 1 to this, and when you're going to add a 1 to this, what happens is, yeah, again when you're going to add a 1 to this, what happens is, here it will be 0 1, it will be 0 0 here, 1 1 here, again sign bit remains as it is. Sign bit remains as it is. So this is how the output is going to be. It is nothing but 6. So minus 6, right? Okay. Okay, this is nothing but minus 6. So let's see the output. Output is also minus 6. So whenever you take NOT, it is not like directly you take an AND and that's it. Directly you take the complement that and that is it. It's not like that. First you take complement. If this is A, then what you take is, you take the complement here. Okay, so the output that you're going to give is a 2's complement. Then you take the 1's complement. Okay, then you are going to add 1 to it, and then you get the 2's complement. This is how a NOT operation is done inside the compiler. So here and the last bit is going to be the sign bit. So whatever is it, if it was 0, finally you get as 1. Okay. Suppose let's do it in the reverse operation. If you want to get from here you got from 5 you got -6. Now let's just try the 2's complement of -6, then you will get 5. Okay. First you have to take the complement. Then you add 1. Then you again take the complement. Let's try out that also. Now just see how the NOT operation is done. If you have got the input as 5, first you take the complement and change the sign bit. Now let the sign bit remain as it is. The rest of the operations will be done only in the 4 bits. And here then you take the 1's complement and then you add 1 and take the 2's complement. So if you want to go in the reverse order, what happens is you have got suppose -6. -6 is nothing but sign bit is 1 and you have got -6 is something like 1 1 0. Okay, so first you take the complement, just take the complement. Now after completing this complement section, you have to take the sign bit as it is. Next you do the add 1 to this. You're going to add 1 to this step. Okay, now the output is going to be 0 1 0. Okay, this is as it is. This 0 1, right? 1 0. No, this is going to be 0. This is going to be 1. This is going to be 0. It's going 0 1 0. Okay, this is going to be the output, and again you take the complement. Sign bit as it is. You take the complement, you get a 0 1 0 1. Okay, so this is +5. So what you do is, this is your -6. First you take the not operation of -6. Then what you do is you take the add +1 complement, 2's complement. You get the output, and then to this output what you're going to do is this is the output, and to this output you're going to take the complement and you get this as +5. So this is a reverse. -6 you get +5, +5 you get -6 when you NOT it. Okay, this is how you do the NOT operation. Now there are various programs that you can do using bitwise operators. You can swap 2 numbers using bitwise operators. Then you can find bit positions, and bitwise swap you can do. You can find it is odd or even. There are many programs which we will be doing in the next section. Okay, so let's see you in the program sections in the next video.